Let's show that this given equation is a homogeneous equation. In order for us to do that, of course, this is already structured in this form: m of xy dx plus n of xy dy equal to 0. If it's not, then we need to transform it into this form in order for us to identify m of xy and n of xy. M of xy is this function. You have x squared plus y squared. That's the function multiplied to dx. While n of xy is this. That's the function multiplied to dy. So x squared minus xy. To show that this is a homogeneous equation, let us try to come up with m of tx and ty. If we could convert it to the form of t to the power of an alpha multiplied to the original m of xy, then we are done with the first step. Do the same thing for our tx. N of xy becomes n of tx and ty. If we could also come up into this form, then we're closer to our goal. The last step is just to make sure that the alpha here is same on both equations or functions. If it's not, then this is not homogeneous. So let's start coming up with m of tx ty. What does this mean? We simply change our x and y on our m function into tx and ty respectively. Hence, the x squared becomes tx squared and the y squared becomes ty squared. Using the laws of exponents, you have t squared x squared plus t squared y squared. Factor t squared on both, since t squared can be found on both. So what is left on our first term is just x squared plus your second term, which is just y squared. What was this function? That's the original m of xy. Hence, simply substitute it here. So you have t squared m of xy. We are done transforming m of tx and ty into this form. Hence, we can now say that the alpha here is 2, as this is the exponent of our t. Now, let's proceed to our n. N of tx and ty. Again, change x into tx and y into ty. So in this given function, you will have tx squared minus tx, that's for our x, and for our y, ty. Loss of exponents, t squared x squared, and the product here, sorry, that's just simply minus, the product is t squared x y. Same thing, factor out t squared, you will have x squared minus x y, and this was the original n of xy. So you have t squared times n of xy. Here, the alpha is still 2, as that's the exponent of our t. Since both were transformed into these forms, giving the same value of alpha, we can now say that the given equation is a homogeneous equation. And if we are to solve this, we will be using the processes involved in solving a homogeneous equation. Please wait for that video. Thank you very much for watching.